Creating and using scenarios in Excel with me, Duncan Williamson, October 2025, Between the Sheets, Excellence since the year 2000. The purpose of this video is to introduce the idea and application of scenarios using Microsoft Excel. We'll look at the definition of a scenario, examples of the use of scenarios, creating scenarios, and then using various Excel approaches to scenario management, and the results. What have scenarios done for your model? First of all then, what is a scenario? Well, in general terms, a scenario is a descriptive and structured account of a possible situation or a set of events, and it's often used to explore outcomes, test assumptions, prepare for decision-making under uncertainty, and stand as a basis for sensitivity analysis. And while the ideas behind scenarios might appear abstract, their application is entirely based on practical application. Examples of the use of scenarios. Well, let's consider some ideas of the use of scenarios. Let's imagine I'm preparing a business plan, and in that plan, I would like to generate 3 scenarios for sales units along the lines of optimistic, expected, pessimistic. And my products are, let's say, smart home devices. And my key assumptions are market growth rate, market share, sales conversion rate, production, and supply constraints. So here's the table of those metrics already set out. I will take, these are the inputs, and we'll apply them in the way that you might expect. For example, using these, what I've called here, scenario calculations. Sales units equals market size times market share times the conversion rate. And revenue equals sales units multiplied by the average selling price. And here we are, by way of the example, when we have an optimistic scenario and market size is 1 million units, we have a market share of 12%, and we assume our conversion rate of those 12% becomes sales units of 36,000 budgeted or planned or forecasted for at a price of 120. That gives our optimistic revenue $4,320,000. Expected is $2,475,000, and pessimistic 1,280. The optimistic scenario assumes stronger market growth and higher conversion rates, producing sales of 36,000 units and 4.32 million in revenue. The expected case reflects realistic historical averages, a base forecast for planning, and the pessimistic case stress tests your resilience, where sales fall to 12,800 units and revenue drops to 1.28 million. Introduction to scenarios. We don't see anything unusual. Assumption, line items, and then the optimistic, expected, pessimistic values, parameters, variables, and notice they're all hard-coded. It's a true input section. Everything is hard-coded, so nothing to worry about there. In this worksheet, we are beginning to use some formulae now, and here's the first one, and I'm leveraging the dynamic array functionality of Excel now by using this formula. It's an XLOOKUP dynamic array function, F5, go to A5 to A9, not A10, because I'm not introducing the price inflation rate just yet, so we can ignore that one for now. And then go to B5 to D9 to find the appropriate value, which is here, here, and here. So it's dynamic rather than just do equals A5 equals B5. We use that. And the same, XLOOKUP, the same, all the way down, the same, or something very similar. Notice how I've amended the names to make it work. For example, we see average selling price there, price here. Sales units, there's, first, let's call it the real formula. G5 times G6 times G7, that's where the 36,000 comes from. And then revenue, it's G8 times G9, and there you are. And we copy those across. In that case, we copy those across. I could have done it this way. Let's do it. I'll show you here. Equals all three prices times all three sales units. Press enter. How about that? So we can get rid of that. Move this, promote this. And we can do the same there. That's for you to do. You try that. And now we have what I've called scenario 1. It's essentially the same as the base case, with maybe a little bit of a difference. First of all, it's formatted. Secondly, I'm showing you the market share units, which I didn't do over here. So although we did the calculation to derive the 36,000, I'm now shown in full. That means we could have chopped this table out, didn't need to do it, but just by way of a development and a bit of variety. And look at the formula. L5N5 times L6N6. Again, the idea of the dynamic array functionality in Excel. You haven't seen this yet. I've mentioned this table on the right-hand side there, top right-hand corner, with year 4. But obviously I couldn't demonstrate in the PowerPoint how you make that work. Scenario 2 and 3, reduce, there's the full version. Here we just have 3 lines, 2 lines. Let's see what happens. Market size, the base size, let's have a look at the cell. B5, D5, just ordinary copy over from the input section. Adjusted market size, Q5, times 1 plus B6, that's the market growth rate, to the power of S3 minus 1. That gives you essentially year 0, year 1, year 2, year 3, year 4. Let's check that. It's a data validation cell, says 1 to 5. So I click on year 1. For year 1, I don't want to cause any change from the base case to adjusted market size for year 1. It's assuming at the end of year 1, and we assume the investment or the sales were all at the end of year 1. Right or wrong, that's what I did. If you believe it should be at the beginning of year 1, then this formula, you would cancel out the minus 1, and then you would inflate from 1 million to whatever it is for the end of year 1. So there we are, year 1, 1 million, 120, the same. Make it year 2. And now, because it's 15%, 10%, 5%, it becomes 150, 990, and 840. And then your market share, 12, 10, and 8%, that's 12% of that, 10% of that, 8% of that. Quite straightforward. Let's have a look at the scenario 3 now. So converted sales from 138 times L8 to N8, we're over here, and then revenue B9, D9 times Q10. There. Notice no price inflation, not yet. And then I've added this rate of change from the base then. Let's see what that is. It's Q11 divided by G10 to I10 Take it from there. The base case, -1. And so 50% change from year 1 to year 2, 10, 5. Let's change it to year 3, 32, 21, 10. Year 4, 52, 33, 10. Cumulative percentage, year 5, 75, 46, 21. Going step by step. You've seen all of this, all of this. These are new. These are new. What I did was I created 2 data tables to show the revenue for all 5 years for all of the scenario bases. How do we do that? Well, I do the calculation here, G21. What's in G21? Let's find out. Down here, my revenue for year 4. It doesn't matter which one I choose there, year 4, 3, 2, 1, or 5. It would still give me the different answer, but the right answer is here. And then the same for expected, still year 4, pessimistic, still year 4. And then, because this calculation uses this input, when we do the data table, we use I13 as the column, as a column metric, which is in I13, which is this one. So that's the foundation. There's the formula from down here, and there's the column variable to drive that table. In this data table, we're using the rates of change here, what if analysis, data table, based on the rate of change, and I want to nominate the column input cell, which is again year 4. There we are. Year 1 is 0, because I've assumed everything happens at the end of the year and we don't do anything during year 1, no changes, no inflation, no growth. And so it's 0% for year 1 and thereafter, as you can see. There we are. Data tables, really very powerful. And there's your sensitivity. And the charts, by the way, come from here. From here. This is based on the revenue and the rate of change. Revenue, rate of change, revenue, rate of change. And I've kept the vertical scales constant across all 3 of these charts. Let's start with the ordinary Excel formula here. Let's see what I've got. In this cell, it's just a reference to cell B9. I've kept all these tables on the sheets the whole way across. So from B9, there, transpose J22, J26, Y, J22, J26, there you are, that's that one, to turn it from a vertical to a horizontal, the same for each of the scenarios. Keep it very straightforward, and it doesn't need to be complicated, because they've done all the work already. And then the revenues, they are T46 times T47. And it's a dynamic array function because of the hash symbol there. So I don't need the dollar signs. And you'll see something very similar for expected and very similar for pessimistic. Notice here, this is my lambda function, which I'll share with you in a second. You should find the answers are the same. Concentrating on the bottom line, revenue, they are. Year 2, are they exactly the same? Let's go to year 5, are they exactly the same? No, not quite. There's a difference of, what would that be? About 27. It's a tiny difference, 27 out of 7.5 million. And what's the lambda function? Well, actually, I created a user-defined function. So in here, what you'll see, all you'll see is scan scenario table option 1, option 2, option 3. So where's the lambda function? Well, it's over here. Let me show. This is the lambda function. You can download this file. You can explore this to your heart's content, but it begins with the lets, a couple of lets, and then eventually it gets down to the lambda when it puts it all together. I've done lambda and ordinary calculations. If you don't understand lambda, or you don't want to learn them, I understand, then you don't have to. I've done both options. And the same with price inflation. What have I got here? Ordinary equals B9, and now I'm using AA46, this one, to multiply by 1 plus B10, and in B10, what do we find? The price inflation ratio, percentage rate, 3, 2, 1. Apart from that, you'll then find the other calculations essentially the same. The formulations are essentially the same, but the difference is 432, 432, 7555, 8504. The compound effect of 3% makes a big difference, about $1 million in 5 years. 247, 623, 362, 120, 1280, 1555, 1280, 1619. The lambda function, here it is. I've created another user design function, which is called scan table inf. And actually, this is the lambda function for that one. Again, download the file and see how I did that. See what I did and how I did it. And then what this lambda function is looking for is a bit different from that one, is it's looking for these. So actually it's a little bit clumsy in that it's asking you to do this. Equals scan underscore table underscore infl, open, and then select B4 to D4, comma, select B5 D5, comma, as you can see. So you're having to go to B4 for the name, B5, B6. That's what they are. That's what it's telling you to do, to put those values in. And then it all comes churning out. Again, 4320, 755, 8503, 8504. Again, a very small difference. Rounding error. There you are. Anyway, there you are. That's a good introduction to scenario management, scenario analysis, scenario usage, setting up and usage. And it's a relatively simple case exercise. But if you take it step by step from there to the end, you'll have done a very good job. Okay, well, there you are. Thank you for watching, and I'll see you in the next one. Duncan Williamson, Between the Sheets, Excellence since 2000.